All right, here we go with part 2 of geometric series. We're going to start off this part with a new definition for you, a new term. That term is annuity. An annuity, as defined in this text, is a sequence of equal investments made at regular intervals. Now, if you ask me, that's kind of a vague definition, so let me give you just a little more information to explain it. So an annuity is a kind of insurance product that pays out income. And a lot of times it's used as part of a retirement strategy. Annuities are a popular choice for investors who want to receive a steady income in their retirement. So how it works is you pay into this annuity, and then later on, it will make payments to you. And so what we're going to see is the future value of an annuity. So this is looking at, okay, so we've invested money into this. What is its payout going to be for us? That's what we're going to learn how to compute. And it is found using this formula here, where FV is future value, P is the periodic payment amount, I is the periodic interest rate, and N is the number of these periodic payments. So let's look at this example and use that formula. We're going to try and determine the value after 40 years. So this is like your entire working career of making $75 monthly into a monthly annuity, paying 4.8 APR, and this is compounded monthly. So the first thing we need to do is determine the monthly interest rate and the number of payments, because 4.8 is our APR. APR is annual percentage rate, so we have to divide that into a monthly rate. That's why we're dividing by 12, which gives us 0.004. Okay, now to find the number of payments made, it's 40 for 40 years, and 12 because it's every month in those 40 years, which is 480 payments. Okay, so now we're going to substitute these values into our formula, and I will give you a little time. Why don't you pause this video and find that value on your own. Make sure that you can do this in your calculator, and if you can't, then put a little note in your margin of your notes so that we can be sure and do this together. So pause this video and try that right now. Okay, so what we should have is $108,654.10. So you'll see that really for making so many payments for so many years, it's not like what you see with compound interest, like we saw with investing earlier in the year, but it is one of those options. So let's now talk a little bit about geometric series, infinite geometric series, meaning that this series goes on and on. It's not stopping. So what happens when your rate is less than 1? When the absolute value of your rate is less than 1, that would be something like 1/2 or 1/3 or even a negative 1/4. What's happening is it's going to converge to a particular sum, and that sum is found using this formula. So that would be if your n went on to infinity. Now, contrast that with rates that are greater than 1, like 2, -3, 26. They are going to diverge. They are going to just grow beyond a sum, beyond a value that we can find. So in this example, we're going to determine whether the infinite geometric series converges or diverges. And if it's converging, we want to find its sum. We want to find what would be the total sum of this infinite series. And I know that might sound crazy that you can add an infinite number of numbers and actually get a number, but together in class we're going to go through an explanation, a visual demonstration of this. So, is this going to converge or is it diverging? We have to look at the rate. Our rate is -1/2, and because the absolute value of that is less than 1, it converges. And to find that value, we plug in our rate into our A1 into the formula, and that gives us the following. That looks kind of crazy. It's 1 divided by 3/2. So that would be 2/3. If you add up all those fractions and notice they're getting smaller and smaller and smaller and smaller and smaller, all of them together will only give you 2/3. Okay, now this example. Looking at it, you can see, it was not animated, our rate is in fact 3, and because it's 3, our series is going to diverge. We wouldn't be able to find the sum because it's too great. We cannot find that value because this model is just going to grow and grow to infinity. We can't add that large in numbers.